Hi, peeps. This is video number 5. So let me grab a pen here. Name. Video number 5. This is Algebra 2. And this is 1.5, solving absolute value inequalities. All right, so there is something new in here that most of the time, many of my students have never been exposed to before. That's something we're going to talk about called interval notation. But first, let me kind of give you an idea and give you some hints here. So the first thing I have to say is that when you solve these, when you're doing your work on paper, when you solve these, be sure that you also graph them on paper before you just go put them in varsity, because that will help a lot with the interval notation we're going to talk about. Okay, so that's just kind of something I would do, a hint. I definitely do on my own when you do these. So let's talk about how to solve the inequality. And at the beginning, these are very similar to what we did in 1.4, where you were solving absolute value equations. And remember, we had the whole case 1, case 2. You're going to have that here as well. And we're going to have some of the same questions. So we're going to start out with the example. Absolute value of x minus 5 is greater than or equal to 2. Now, you're going to do, excuse me, same thing you did before. The first question you're going to ask yourself is your absolute value equal to some number? And only some number. And in this case, yes, it is. So you're going to move on to, remember, let me just quickly review. That meant that you had nothing in front of the absolute value bars and nothing between the absolute value bars and your equality, or in this case, inequality symbol, right? It's just absolute value and then some number on the other side of the equal or inequality. All right, so step 2 is the number, and by that we're talking about that one, positive or 0. And as long as it is, in this case, yes it is, then you're going to continue. And step 3, you're going to do case 1, case 2. And we're going to have a little bit of a difference in case 2 this time. So case 1 is going to be just like what we did last time. Remember, we dropped the absolute value bars and just left the answer on this side positive. Case 2, however, there is going to be a change here. And that change is that you are not only make the answer negative, you are also flipping the inequality symbol. When you do these. So this is going to look like x minus 5. We're going to take this and flip it. So it's going to be a less than or equal to, and we're going to make this negative. Okay, so that's how those two things are going to change. Now we're going to go through and solve the way we did before. So I'm going to add a 5, and I get x is greater than or equal to 7. That would be one of my answers. Add a 5, and x is going to be less than or equal to positive 3. All right, well, after that, I want you to make sure you graph these on your paper. And by that, just draw a little graph. 3 is less than 7, right? So I'm going to put the 3 here and the 7 here. We talked about in the last 1.3, actually, from 1.3, Remember that if you have an open dot, you have those two symbols and a closed dot as those two symbols. So because we have a greater than or equal to here and a less than or equal to here, we're going to have solid dots on both of these. And then if I look at the x, these don't go the way I intended them to go. Did I make a sign error? Hang on one second, please. Did I just plain make an error? Oh, I did these wrong when I did them on my notes. All right, well, so what's going to happen here is we are going to, if this left-hand one, where 3 is the smallest, if x is less than 3, then we would shade this way. And if x is greater than or equal to 7, we would shade this way. Okay, so I highly recommend that you put that on your paper so that you can then do your interval notation. Which we will come back to this graph that we just did in a few minutes. But I need to tell you what the interval notation actually does. So interval notation, this is one of those big old, you should probably highlight this if you're using highlighters. Make sure that that's all highlighted so you can go and find it. Again, from experience, this is one of those things that students need to see a lot. You're going to see a box in varsity. Let me go show you. A box in varsity that says, put your answer in interval notation, and it's right at the top. Then the graph comes under that. I would do the graph first and then let your graph tell you what the interval notation is going to be. Okay, but that's the reason we're doing this, is because it's going to be in the varsity problems. So here's what you need to know. Interval notation is basically, it tells mathematically what the graph says. In mathematical language, so it tells us where the shading is, what the solution set actually is. And so here's something that we need to talk about. Let's go back up to the graph that I have up there. This thing, if you go out, forever and ever and ever and ever, off the paper, all the way down here, what is down there? There's a number that you can approach, but you can never touch. It doesn't have an actual name, but it is negative infinity, right? I'll actually write that out. Infinity with an I. Okay, negative infinity. Looks like that. Infinity signs are terrible to draw. They're little sideways 8s and they're super wacky. And the same way, if you were to keep on going all the way out here forever and ever and ever, you would eventually get to positive infinity. Always in that order. Negative infinity is always going to be on the left-hand side of your number line. Positive infinity will be on the right-hand side of your number line. So you could actually draw those in here. This arrow up here on the graph that I'm now highlighting in green approaches negative infinity as it goes forever and ever and ever off to the left. As it goes forever and ever and ever off to the right, it's going to approach positive infinity. Okay, and I'll tell you in a moment why those are important. Interval notation itself is a shaded area. So interval notation, it basically says the shaded area on the graph is represented. It's kind of hard to come up with words for these sometimes. Inside a combination of parentheses or bracket, I don't need a comma there, parentheses or brackets, or a combination of the two. And what that does is it shows the lowest value to the highest value, and you separate them with a comma. Okay, so here's the next thing that you need to know. If you have an open dot on the graph, that's represented with parentheses. Let me make an amendment to that. An open dot or infinity or negative infinity is going to be represented with a set of parentheses. A closed dot on the graph will be represented with a set of brackets. And those look like that. On the keyboard, they are to the right of the P, and you don't need a shift key. So the shift key, you would get the little French squiggly brace that looks a little funny and are hard for people to draw. No shift key, you get the brackets. All right, so let me give you an example before we go back up to the one at the top of the page. Here's some examples of interval notation and how it actually works. So if you have a graph, and let's say you're talking about -2 and 6, and on that graph, they both have a closed dot, and then you have shading in between them. Now, up here in this purple, it says that a closed dot is represented with brackets. So we're going to have a set of brackets. You're always going from, again, up in blue, the lowest value to the highest value, left to right, lowest to highest. So we're going to start with the -2, and we're going to go up to 6 because all the areas in between are covered and separated with a comma. So this is an example of what the interval notation for that graph would look like. Okay, let me do another one. We're going to do a bunch of these, and then we'll get back to actually doing a problem. So if we have a 17 and a 48, it does not matter how far apart these things are, and we have open dots on both of them, then we're going to have a parenthesis, because up here, open dots in green are represented with parentheses. Your smallest number is a 17. Your highest number is a 48. Parenthesis after the 48 because of the open dot right here. Okay. Another example, you could have a combo of the two. Let's go from 0 to 4/5. Don't worry about the numbers and them being fractional. Let's say this is a closed dot, open dot, shading in the middle. Closed dot gets a bracket. Your smallest number is 0. You're going up to 4/5. 4/5 has an open dot, parenthesis. So that would look like that. Okay, that looks wacky, I realize, but let me just quickly take you over to Varsity, and I want to show you something. Varsity. If I click in here and go to the builder, in here you have 4 tabs now: basic, intervals, functions, and trig. I'm going to click on the intervals, and look, you have a set of parentheses, parenthesis bracket, bracket parenthesis, bracket bracket. Negative and positive infinity are also in here. You see a U. We'll talk about that guy in a minute. So you can go here and type in all your intervals, or you can just simply type because they're all things on your keyboard. How do you type in infinity? You type 2 lowercase o's, literally o's, not zeros. Okay, we'll talk about infinity though here in a second. All right, so let's talk about that guy now. Let's say I have one value and it's -7, and my graph goes from -7 with a closed dot, and it goes forever and ever in this direction. Well, remember, you need 2 pieces of information in an interval notation. So my graphing, the green part, starts at 7, -7, and that's a closed dot, so bracket. And it's going to go off the graph. Well, off the graph means it's going to infinity because it's positive. So I'm going to go to infinity. Infinities always get parentheses. Okay, so that would look like that. So here's what you could type in varsity. You could literally type bracket -7, comma, lowercase o, number or letters, letter O's, lowercase, and then the parenthesis. And you should see a symbol. It will translate it into the preview that looks like a infinity sign. Okay, we got to talk about one more. Well, let's talk about 2 more. Let's go 12. And this time we're going to go open dot. We're going to shade left all the way off the end. Okay, well, off the end to the left means negative infinity, right? I would, oh, that's not very readable. I would label these on your graph the way I have been doing to help some of you who have trouble visualizing this stuff. And we're going to go to 12. Now, we're going least to greatest. Well, least is the negative infinity, and they always get a parenthesis. We're traveling left to right on the graph, and we hit 12. So comma 12. And then the 12 is an open dot, so it gets a parenthesis. All right, well, our graph, let's talk about ours. I'm going to scoot back up here. We have this guy. I'm going to actually, let's see if I can take all of this. I don't know if this is going to work. I'm going to try. Copy, zip down here, paste. All right, so that's what our graph looks like, right? I am going to actually erase this part. I'm going to erase these little dots over here. All right, so this part's super important. You have, in this problem, 2 pieces of shading. On the graph. So that means you need 2 pieces of interval notation to represent that graph. Okay, so let's talk about, and really the solutions are this and also this, right? So here's what we're going to do. We're going to do a piece of interval notation for this side, which is, we're going to go from negative infinity up to 3, negative infinity up to 3. Infinity and negative infinity always get a parenthesis. The 3 has a closed dot, so it's going to get a bracket. Now let's do this part. We're going to go from 7 to infinity. The 7 has a closed dot, so it will get a bracket. Infinity always gets a parenthesis. And when you have 2 pieces of interval notation, you need to put the symbol that represents the word and that symbol is a capital U on your keyboard, or the U that you saw in varsity. All right, so you would quite literally type this whole thing in, parenthesis negative infinity, comma 3, bracket, capital U for union. That's what this means. You're unioning your answer, this part and this part. And then bracket 7, comma, infinity, parenthesis. All right, so that would be what you would need in varsity for that. All right, let's do another example, maybe just one more. and go from there. Woo! Sorry, my husband is home and my dogs are freaking out. Extra credit if you tell me their names. You ready? I have 2 pit bulls. They're going nuts. The 2 pit bulls' names are Rory and Jade. That's Jade. And then I have a little black mutt thing named Dixie. You can get extra credit in your notes if you tell me what my dog's names are at the end of this thing. They're probably going to bark again when he actually comes in the door. I apologize now. Okay, next page. First, make sure if you're done with a page or not, you're at 1.5. And we're going to go forward and do another example. Okay, so let's look at this one. Absolute value of x minus 7 is greater than or equal to, oh, geez. All sorts of things are popping up. Greater than or equal to -4. Now, remember, yes, I know this is a negative over here, but remember your first question. Is the absolute value equal to just a number? In this case, no, it's not. So we need to fix that. And again, for those of you struggling, that means, is there anything before the absolute value? And is there anything after the absolute value before the equal or inequality symbol? In this case, yes. So we need to get rid of that. So let's add a 7, add a 7. So now we have absolute value of x is greater than or equal to 3. So now this is no longer a no, but a yes. And question 2, is the number positive or 0? And the answer to that question is also yes, so we can continue with case 1 and case 2. So 3, do both cases. Okay, so case 1 is just, oh, I don't need that absolute value bar, is x is greater than or equal to 3. Like, done. There's nothing to do to it. Okay, and then we have case 2, which is x, we flip this around, less than or equal to, and then we negate this and make that -3. Okay, so there was no actual math to do. This was a little bit simpler question. And then let's graph it on a number line. So we're going to have our lower number, even though it's on this side, that's our smaller value. And then our bigger value over here. And then let's graph some stuff. So each of them need a solid dot because of the symbol that they have. And then if we look at the smaller value, x is less than -3. That means x is less than, and it's going that way. The bigger value, x is greater than 3. It's going out this way. This isn't always going to happen, by the way. Sometimes they're going to go toward each other, and then you'll just have one piece of interval notation. So now interval notation, we have a -infinity here, positive infinity here, and we're going to go paren, -infinity to -3. Closed dot is a bracket, union in between, bracket, 3, comma, infinity, paren. If you did that well, good job. Also, I want to encourage you again. I mentioned this in an earlier video, but remember, you can pause, do the work, and then see if you did the work the right way. That's the best way to double check that you're actually understanding and grasping what's happening here. All right, one more example. Remember, this is 1.5 before we finish. So one more example. And this one is absolute value of 2x minus 1 minus 4 is less than or equal to 7. So, question 1. Question 1. Is the absolute value equal to a number? And again, in this case, it's a no. So we need to move that number. So we're going to add a 4, add a 4. Now I have absolute value of 2x minus 1 is less than or equal to 11. So now this is fixed. Now 2 is the number positive or 0. And yes, it is. So we're going to go case 1. I know it gets repetitive writing this stuff over and over again, but it's really hard to figure out what you did if you don't show very, very clear steps. So case 2, remember in case 2, we're going to drop the absolute value, switch the symbol, make the answer negative. All right, let's solve both of these simultaneously. Add a 1, add a 1, add a 1, add a 1. So we get 2x is less than or equal to 12. 2x is greater than or equal to negative 10. Divide both sides by 2, and you get x is less than or equal to 6. X is greater than or equal to negative 5. All right, again, I skipped a step. If you can't, make sure you show it. Now let's graph. Smaller number on the left, that would be the negative 5. Bigger number on the right, that's the 6. And then they both get a solid dot. We didn't have too many open dots on these. And then from the smaller one, x is greater than or equal to negative 5. So that means it's going to go that way. And you're not going to shade past a dot. So if you go from negative 5, you're going to stop at that dot. You're not going to go past it, okay? And here, x is less than 6, so you would start at the 6 and go this way and stop at that one. And you're done. Now you need your interval notation, solid dots, brackets, smaller number, comma, bigger number, and you're all finished. Okay. There are a couple of other problems in here that have some fractions. I'll let you deal with those, see if you can figure those out. So we're going to have notes. You're going to submit those in Classroom. And then you're going to have a varsity assignment, and that will be associated. And this is the end of chapter 1, which means we're going to have a day, I think, for a quiz review in class. If you need more time than that, you need to manage your time correctly and work on it outside of class. We'll go over it the next day. If there's questions, we'll do them at the board. And then you guys will have 2 days to take that test. And this is your first test for me. So when you take a test, what we're going to do, and I'll re-explain this later, but you will take most of your tests on varsity. You will still have 4 attempts per problem. But let's say it's a 1-point problem. You will lose, and this will happen no matter what, you will lose 10% per incorrect attempt. Okay, so what that means is you start out with 100%. If you have to do it again and you get it right, you earn a 90 or a 0.9, right? So this is a 1, this is a 0.9. If you do it again, you would earn a 0.8, which is an 80. If you do it again, you can earn a 70, which is a 0.7. And if you don't end up getting an actual score, if you miss all attempts, and get a red X, which means you got 0 points, you can message me and turn in your work. You can turn in your work on Google Classroom. Highlight the work you want me to do, literally with a highlighter. Or not have me do, but have me check. Highlight any work you want me to check. And I'll know that you turned something in on Google Classroom, right? So here's the deal. If you got points for it, let's say you got I don't know, 30 out of 31 on the test. You did really, really well. You do not need to submit your work to me. I don't need to see it, period. But if you missed some problems and you want me to look for partial credit, I will do that for you. But the process, you need to turn it into Google Classroom, highlight any work you want me to check, and I'll go back over this before we do the test. and then I can award you points and give you partial credit on those things. Okay? So that's how a test is going to work. Tests will be taken in my classroom. So if you miss a test day, that's something you're going to need to make sure that you make up. We have a couple days in class that are set aside as catch-up days. But if you have a study hall or you can come out of lab or something, if we're actually physically in school, then I would have that expectation that you're going to do that. Also, if it's a 2-day test and you are not done yet, I will happily give you a third period. You just need to find that time on your own in which to do that. Okay? I'm not going to cut off your time no matter what. So that's how that's going to work. All right, guys. Toodaloo.